With its latest game-changing breakthrough, BYD hopes to revolutionize the EV sector. Competition has become tight. Buckle up because the future is about to get electrifying. Battery 2.0. The second largest EV manufacturer in the world behind Tesla, BYD, is also one of the top battery producers in the sector. It just began supplying Tesla with reasonably priced iron phosphate batteries for the entry-level Model Y, but shortly its investment is less expensive than chemistries and will be increasing with sodium-ion cells. BYD Chairman and President Wang Chuanfu stated in an online launch event that the theme with the Blade battery, unsheathed to safeguard the world, is that the Blade battery demonstrates BYD's commitment to resolving the battery's safety challenges while also redefining the norms for the whole industry. BYD featured a video with the Blade battery surviving a nail penetration test, which is regarded as the most demanding method of testing by the thermal runaway of batteries due to its extreme difficulty. According to Professor Kwangmin Gao, a member of the Chinese Academy of Sciences and a professor at Tsinghua University, BYD's Blade battery has obvious advantages in terms of battery safety and energy density. A joint venture agreement for the commercial growth of its sodium-ion battery production has been entered into the EV battery company FinDreams, which BYD spun off a few years ago. The Huawei Holding Group, using BYD's manufacturing know-how and Huawei's broad network of sales and marketing, the two will build the largest sodium battery facility for tiny electric cars. Safer than lithium. The Blade battery only attained a surface temperature of 30 to 60 degrees Celsius during nail penetration testing and did not produce any smoke or flames. The surface temperature of a traditional lithium iron phosphate block battery reaches hazardous levels of 200 to 400 degrees Celsius under the same conditions, whereas the temperature of a ternary lithium battery hits around 500 degrees Celsius and burns fiercely. This proves that even when there is considerable damage, EVs fitted with the Blade battery should be far less likely to catch fire. Additionally, the Blade battery passed testing under exceptionally difficult circumstances, including being crushed, bent, burned to 300 degrees Celsius in a furnace, and 260% overcharged. None of them resulted in a blast or blaze. Safety has been neglected in the development of power batteries as a result of this impractical emphasis on energy density. With the Blade battery, BYD hopes to shift the industry's shaky attention away from the important issue and put the battery safety back into the spotlight. Cheaper as well. The cell-to-pack design BYD adopted in its Blade batteries is said to have increased the energy density while also making them even more cost-effective. For those who are unaware, any electric vehicle's battery pack is designed as such that a group of individual cells is enclosed in a frame that safeguards it from heat and vibration. This unit is known as a module. The battery pack is composed of several units. BYD has chosen to bypass the module stage and incorporate its cells directly into a smaller battery pack, boasting enhanced safety. Less packaging means cheaper, smaller, and lighter packing overall, which raises the energy content of the pack level. On a cell level, it is crucial to keep in mind that Blade batteries are stated to have a power density of around 160 watt-hours per kilogram, which is comparable to that of a traditional LFP cell. The showstopper. The Shanghai Auto Show was alive with a wide variety of brand new, primarily electric vehicles or plug-in hybrids with different colors, forms, and price ranges. However, the latest EV, Seagull, had stolen the show. This little car is not only reasonably priced, starting at $8,484 domestically, but it also comes with some intriguing new battery alternatives, such as BYD's lithium iron phosphate Blade. The sodium-ion battery, as well as a well-researched replacement for the lithium-ion batteries, is the true protagonist of this tale. The business claims that the sodium-ion phosphate chemistry used in BYD's Blade battery is more environmentally friendly, less expensive, and safer than lithium-based battery packs. On BYD's E-Platform 3.0, a low-cost EV called the Seagull will function. It will have a peak speed of around 130 km per hour and a 55 kilowatt or 75 kilowatt TZ180XHS engine that is driven by an LFP Blade battery with a 400 km CLTC range. Those are really astounding numbers, and it marks a key milestone for the EV sector as a whole, as well as BYD, with many others are likely to follow. Amazingly, BYD claims that the Seagull sedan's sodium-ion battery will have a 500-mile range. Naturally, before we get too excited about the sodium-ion battery, it is important to keep in mind that while being used for previous 2 years, sodium-ion chemistry is still relatively new to the battery sector. Although BYD deserves credit for avoiding and putting a car out on the road with one, however, the Seagull will initially only be offered in China in order to monitor its performance. So what are your thoughts on this power-packed innovation? Would you be interested in owning a Seagull?